I'll click both these profiles. I will right click on them. I will say insert node. I want to insert node at a distance of 2.6. Maybe just a minute. It will be, what is the length of the member? It is 4.03. 4.03, and from here I want a distance of 1.4. So the remaining distance will be 2.63. So I'll click on both these profiles. Right click, insert a node at a distance of from the starting 2.63. I'll just say okay. You made changes, so okay. Yes. So this distance, it should be approximately 1.4. That's fine. Now when I go to properties, now I don't want ISMB. I'll just delete this if you're not okay. Now I don't have anything assigned to this. Now I want to assign tapered section. So for the tapered section, we have this option to define it separately. I'll go to define. I'll say tapered I section. Here, if I choose tapered I section, you have these various parameters which you should assign. First, we will go on to assign the column, depth of the start node. I want my depth at the starting to be just 0.1. Thickness of web 8 mm is enough. 8 mm thick web. Everything is in meter, so you should choose accordingly. F3. F3 is the depth of the end section. At the end, I want my depth to be 300 mm, so 0.3. Width of the top flange, I just want it to be 140 mm wide. And thickness of the top flange, thickness I will go with 10 mm. If you don't provide any value for F6 and F7, it will take the same value as F4 and Fy, because at the top and bottom flange we want same value, so we can just write let it remain 0. Okay, so at the bottom we have taken just depth of 100 mm. At the top we have increased the depth of web to 300 mm. Web thickness we have taken as 8 mm. Flange thickness we have taken as 10 mm. And the width of the top flange we have taken as 140 mm. Now you might be wondering how these values have arrived. So these are based on your trial and error. First, you should assign some values and run it. And if any member is failing or if any member has less utilization, you can increase or decrease the values as per your requirement to get the desired output. As we know, if we increase the value of depth, our bending capacity will increase. If we decrease the value of depth, our bending capacity will decrease. If we increase the width of the flange, again the value of Z will increase. That says the bending capacity will increase. So you have to change these values, and with experience you will understand what are the things we should add. So for the column, this is my requirement. Material steel, I'll just say add. Okay, now you can see reference 1 done. Now for the rafter towards my column, now you have two type of rafter, one rafter at the end and other rafter towards the center, because we have broken this in two parts. Okay, so for the rafter towards the at the end towards the start, I want 100, and width also I will take it as 100, width of my flange, and 8 mm and 10 mm, that is fine. And this I will choose as 300 is too much, 280 is sufficient. So it will start with 100 towards the center, and it will go to 280 towards the point of contraflexure. I will just say add. Now I want the third one. It is the same, just this is 200. Okay. If I click on geometry, I am not able to see my nodes over here. So we have the option to see the nodes. Shift K. If you press Shift and K, you will be able to see your nodes. Go in property. I will choose my first tapered section. Use cursor to assign. Click on assign. I will choose both of my columns. Why am I not able to? Fuck. Oh, again we encountered with some error. It closed. Comparison PEB. As this is the software, you should always keep on saving what you have done because sometimes in the middle it might crash. You see, we hadn't saved anything, so the point is not saved. I will just quickly do it. I will choose both of my rafters. I will say insert node 2.63. Okay, go to properties, just delete this, define trapezoidal eye section. Okay, this is for my column. Add for my rafter, everything is same. I just want to change this 300 to 280 and this 140 to 100. I'll say add, and again I just want to change this 300 to 200. We have all three kind of rafters. Now I will save it so that again if it crashes we don't have to do it again. I'll choose my another method is just click on press Control, choose both your columns and say assign to selected beam. Say assign. Yes. Now if you want to see how this is being assigned, you can click on view, 3D rendering. You can see this is being displayed. If you see from the front view, I just zoom it. At the bottom you have 100 depth of the web. At the top you have 300 of the web as we defined. Just close this. Choose both these rafters. Taper to assign to selected beam. Say assign. Yes. Let's see if they are correct. Yes, they are correct. We have this. I'll see in the front view. We have 300 at the end and 280 at the end and 100 at the center. I'll close this. Now we want these two things to be with 3. So first choose reference 3 and then press Ctrl and choose both these members. Say assign to selected my beam. Assign. Yes. I am not sure if they are correct. Just press on them and click on this. Mm, no, they are wrong because we want here as 100 and at this end as 200. So I'll just close this and what we can do is we can just Double click on this and start will be 200 and the end will be 100. Say change. Now you can close. Now if I want to see my whole structure, I just click at the side. Nothing is chosen now. Click on 3D rendering. Now you can see this is our model. I want to see it in the front view. Just zoom it. You have seen we have tapered the section 100 to 300 and from 280 to 100 and again from 100 to 200. Okay, so this is my pre-engineered building as per our my design requirement, and I have chosen this. Material will be steel. Specification not needed in this case. Support we have already assigned. Loading we have already assigned. Again, if you want to see, I'll show you. Let's see if it's applied. Yeah, for both the beams it is applied. Analysis, we have the stat plane. Analysis is also fine. Perform analysis command is there. Design also there. Everything looks great. Just let's run this model. Click on run analysis, say save. Oh, we have encountered with some error. Let's check what are those errors. We have 6 errors. View output file. Just click on done. When you click here, you have this error. And what does the error say? Elastic modulus E not entered. Okay, so we have these 6 members, and for all the 6 member, it is showing the same error that elastic modulus not entered. Means our model is not able to understand that this elastic modulus is a material property. It is not able to understand that we have chosen steel. So what we'll do is click on Control A, steel, assign to selected beam, say again assign. Sometimes this happens. Okay, now maybe it should understand. The same error. Let's see the reason behind this. We have already chosen steel. Steel is chosen. Steel is already chosen. Material defined start. And here you can see end of material tapered. Okay, what we will do is we will assign some other and then again we will assign steel. Maybe it should understand. I'm not sure of the reason. Generally, it should show. What we will do is We will delete this command. We will delete these commands and assign the commands again. Okay. Geometry, properties, steel, 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 material. We have the material as steel. Again, it got closed. Let's, okay, here now it's not showing any material. So I'll just double click on this and I'll choose change. Yeah, now it's showing material. Okay, now we don't have any errors. I'll say done. Just to check the result, again we need to go to post processing. We have the single load case. I'll say okay. Again, if you click on bending moment, you will have the same bending moment because this bending moment is the property of my loading and we haven't changed the loading. So bending moment will remain same. We have the shear force that will also remain safe. We have this axial force. It will also be same, but your members will change. The capacity of your members will change because from ISMB 250 now we have these tapered profiles. To check the utilization, I'll just click on utilization. You can see my column is utilized 98.5%. My rafter at one end is utilized 95.6%, but my column at other end is slightly more than 1%, that is 1.01. You can see 1.007. Then this is slightly feeling we should increase the depth slightly. So what I will do is I will go to analytical modeling. I'll go to properties. This is my third member. Instead of maybe 200, I will have it as 220. Let's see if I slightly increase the depth, it should ideally pass. Again, I'll click on run analysis. I'll say okay. Post processing, okay. Utilization, yeah. Now you can see we have 96% utilization of the column, 93% utilization of this beam, and 98% because we have slightly increased the depth. Initially it was 101, 100.1, slightly it was failing. This now is for the tapered members. What we want to do is we want to check the weight of this profile. If I click on this output, if I double click on steel takeoff, you can see I have three kind of tapered sections. You have these various lengths. What I'm interested in is the total weight. Now we have the weight of 4.264. Initially, what we had is 5.5. So with ISMB, your standard profile, with the weight of 5.5 kilonewton, from 5.5 we have reduced it to 4.2. In both the cases, we had the maximum and ultimate utilization We cannot go beyond this. So you will say, if I use ISMB 200, I will have less weight. Of course you will have less weight, but your member will not pass. Already we have 98% utilization in case of standard section, and we have further reduced the weight with the tapered section, also with 98, around 98, 90, 97% utilization. Now the weight is 4.2. So we have approximately reduced the weight to 20% less. So for a client, if you are giving a model, if you are giving a structure with standard profile, and if you want to use the same thing for a tapered profile, you can reduce the weight by 20 to 25%. So the margin is very high. 20 to 25% is not a small margin. I'll just close this window. We don't need it anymore. I'll close this. Yeah, 98%. I'll close this. So the purpose of my presentation, I wanted to show you this comparison, was only to make you understand the importance of STAD frame and importance of a PEB frame. In case of STAD frame, where we have a particular weight, we can reduce that weight by almost 25% if we use a PEB, pre-engineered building. So this is the importance of pre-engineered building and where it is applicable. We cannot use these pre-engineered buildings everywhere because it will save you around 20%. Some of the disadvantage of PEB is that we need to give much more time to design it. We need to properly fabricate it in our required site. Then we need to use some expertise labor so that we can erect them swiftly in our construction site. This is applicable if we have a large industrial shade. In that case, if our client, if our contractor wants to go with standard and compared it with a tapered section for pre-engineered building, he can have a 25% less requirement of steel, and that 25% will save much of the cost, and slightly he can use that cost to use skilled labors and to have a proper design. Overall, it will still give him a very good benefit. So this is, I have shown you a practical reason why we use a pre-engineered building. And also slightly you have understood how we can use TAD Pro to analyze the models, to design the models. This was just a 2D frame. Now what I want to show you is I want to show you, of course we don't have much time where I wanted to show you this in much detail, how I generally show to people, where I will be showing you how we can model this structure. This I have taken a screenshot from my model, and how we can model this 3D frame and how we can apply various kind of loads to it. Right now in our example of comparison, we have only considered a simple load of 15 kilonewton per meter, just to make you understand the difference between your standard frame and PB frame. But in reality, we have dead load, live load, wind load, earthquake load. Also, we have wind loads coming from all four directions, and how these combinations are done. We have loads on our purlins. So how these all loads are modeled in this, I was not able to show you because of the shortage of time. But what I will show you is the final output. Okay, just I'll go to the folder cold storage project. This was the project. Okay, first I will show you some client specification, what I get from client, general specification. Mm, okay, in general, I have just erased the name of the architect for confidential reasons. Okay, so this was his requirement. He wanted, he gave me a brief of the project. He said that he wanted to building which is used for pre-cooling as a cold storage for the fruits and vegetables for packing of his material. He wanted they used pre-painted galvanized iron sheet roofings, and he wanted a height of 3.3-meter opening, and he had given all the details. His inner length was 40 meter, so my structure was 40 meter by almost 20 meter wide. We had two canopies Internal 7 bays were required, and the different distance between two bays was 4.5 meters. The end bays were slightly less or slightly more than 4.8 meters. He wanted to use ISMB. He was not okay to use the tapered section. He wanted to use ISMB as standard sections. I said okay. Then here he had given me the load requirement which he had. He wanted to design the structure for dead load, imposed load, wind load, snow load, earthquake load. Okay, and we have some erection load, accidental loads. And what are the various load he had given me over here? He had this cable tray, piping, air conditioning duct, which the weight of which was 50 kg per meter square. Then we had these solar panels at the top, which again increased the weight by 20 kg per meter square. Then we had this concentrated evaporators, which had the weight of 500 kg and they were 12 in number. So dead load, live load. So environmental reasons, the location was in Nasik in Maharashtra. Also, you had given the floor levels over here. So all these details were given to me by the architect, by the client. And what I had received this CAD file from the architect, which showed me the plan. You can see this is the plan. The structure was almost 40 meters and 19 meters in width. You had these canopies over here. You had this canopy over here and canopies over here. You have this internal. He wanted everything to be open. He didn't want any columns in the middle. You can see this is the section view. This is the elevation. Here you had this entry. You have this slope. Height was almost 4.5 meter. Then you had almost 2 meters of your sloping. We have these rafters. Okay, so all these details were given to him, and based on his details, what I did is I prepared this cold storage file. Also PEB. I told him the importance of PEB. I showed him with PEB and also as per his requirement with the standard cross section. Let the file open. I will show you. So this was the thing which we modeled. For my bracings, I had given releases. That is where we use this specification. You can see this blue part, specifications. That is where we need it. In my previous thing, we didn't use. Geometry is what we prepare. Properties is the properties for various members. For the bracings, I used ISMC 150. Then for tapered section, we had different properties like we have over in our comparison. Material, everything was of course steel. Specifications at the points where we wanted to give release, we use these specifications. What is release? Means at those point my members won't be rigid. The moment will be allowed in those points. Support, I have this support of pin connection. Loading, you can see there were variety of loadings. If I open this tab, you can see almost I had 1 to 14 loadings and combinations went from 101 to, oh my god, it's around 174. So I have around 74 combinations of load based on our IS code. And I have 14 load cases. Now what are these 14 load cases? First we have these four earthquake cases because earthquake can come in any direction. I have taken plus x plus z minus z from all four directions. We have considered these earthquake loadings. Then we have the dead load. Again in dead load there are variety of loads. First is the self weight. Then we have the various loadings as per his requirement. You can see over here. Then we have these live loads. Again, as per IS code, we have different live loads on the roof based on the inclination of the roof. For wind load, it's very critical. For all the four sides of the wall, I have my wind. You can see wind load over here, one, then this direction away from the structure, then my loads on my rafters. These are inclined loads. Again, at the end, I have half the loads what I have generally. This is one wind load. Again, I have these kind of eight wind load cases. Four earthquake case, eight wind cases, and dead load and live load. These are the various loads which I have. Then, based on these loads, we have these many combinations. And again, after that, we have this envelope. We prepare the envelope based on the strength criteria and next envelope based on the serviceability criteria. Because for strength and for serviceability, we have different load combinations and factors are different. For serviceability, we don't consider the factor of 1.5. For strength, we consider the factor of 1.5. We include dead loads, live loads. For everything, we have different load combinations as per our code. So when I run this, let's also run this. It will take time to run because it's a big model. You can see all my members are being designed. Okay, the design is done. You have 0, 0, 0. That's nice. You can see it took 23 seconds to run this model. If I go in post processing, I can just say okay. Utilization. If I click on utilization, I get all the utilization over here. If I want a table of utilization, I click on layouts, I click on utilization. Here I get the table. See, I have my maximum utilization of 99% also in this case. I have optimized the solution. So higher the utilization, better is the result. Means better is the optimization. So a structural engineer is expected to have to get the highest utilization so that you have optimum utilization of your resources. Do you have any failed members? No, all my members are passing. Let's check the weight. If I have added, I'm not sure. Yes, we have. If I double click on the steel takeoff, now it's 345 kilonewton. This is the weight of my structure. I'll just close this. Okay. I will just close this. Okay, similarly I had for standard, but okay, I won't waste your time showing you the same thing again. Then we prepared these structural drawings. I will show you the drawings what we send to the client. First is the drawing of this footing. We show him what should be the location of footing and what should be this I have done in safe where I have shown him. I have grouped the column and I have given him the requirement of footings, the steel requirement also. Here you can see the schedule of the columns and footings. These are my footings. Next drawing what we gave him is the drawing of the plinth beam level. Here you can see I have given all the plinth beams and we have given the beam utilization and the not utilization, the schedule, the beam schedule over here. Okay. Then we have this beam schedule also for the internal structure. He had some internal offices. So at lintel level, okay, what's important is this one. We have given him the requirement of frame. As per his requirement, I have given ISMB. What we required is ISMB 450. You can see these are the details, everything we need to give in detail. Okay, we also need to give him how to connect the members, the connection detail. We have some Excels where we check this connection. I have prepared some Excels. I'll show you those Excels also. We have the splice connection detail. Okay, and this one is for the roof. So these are some of the drawings which we give to the client, and along with the stat file, which with the help of which he can construct it on site. Now I will show you one more thing. I wanted to show you the Excel. This is the Excel for load calculation. Once we can apply I have calculated the UDL which we should apply on the structure over here. These green things are my output which I will apply on my model. Here I have calculated with the K1, K2, K3, K4, the VZ, PZ, our wind calculation based on IS 875 part 3 based on the openings. Here you can see if you change the wind speed, everything will automatically get changed accordingly as per my location, as per my topography. If I have a hill area, again the value will change. If it's a general area, it will remain same. It's if it's an important building or a temporary building, again the values will change based on those things. I have a general building. So you can see these yellow cells are which I can edit. For CPI, it's based on opening of my structure. If I change this opening, I say no, my structure is open, it's more than 20%. Again, the values will change. This is the sheet for wind load. You can see I have 1 to 8 wind cases, 4 wind cases for plus CPI, 4 wind case for minus CPI, and again for plus CPI we have 0 degree and 90 degree, left to right, right to left. So yeah, I've shown what are the 8 cases. These values we have taken from IS 875 table, CPE, CPI. Okay, so how we can model them quickly with the help of Excel. Here we have shown that. Here I have some earthquake loads parameters. Here I have those combinations for strength criteria and for serviceability criteria. You might have seen this in IS 800, what we have done. Okay, so this was for the loading. I wanted to show you for the connection. Let's see if I have them. Yes, connection. You can see this is the bracing connection. I can choose the members over here. I can enter the height, weight, depth. I can choose the grade of bolt, everything. Here I will get the number of bolts required. Right now I require 2 bolts. Here it will check the welding. Welding is also fine. Okay, so these are the things which we should check for the base plate. If I enter my requirements, I will get the utilization and the number of bolts required. Yeah, we have similarly for the column and rafter connections. These are some of the Excels which we use for the purlin connections. Yeah, okay. I will just close them. Don't save. I already have it. Okay. So that was a small introduction to a real-time project. Hope this helped you. And let me check. Okay, so guys, that was my time.
Sir, I want to ask one question.
Yes.
Actually, many our professionals get confused. What are the system requirements for this type of design to run successful? So we have a confusion regarding this. So it's a technical question that
Mhm.
what are the system requirement for this type of software?
System requirement are basic. You don't need to have a very uh, good means you just have to have a sufficient you need systems to run it. I will just show you what are my laptop configurations.
One more thing I would like to ask, sir, that
Yes.
how how a civil engineer
Mm-hmm.
can start this type of practice in his small town, means structural design practice, how he can start by his own. So a short guideline from you is required.
Okay, so first I will be answering your questions one by one. Just let me check what are my system. See, I just have a 4 GB RAM in my system and it's a 64-bit operating system.
Yes, yes, yes.
Yeah, so it's a basic. I think if you have any of your laptop, maybe even 5, 6 year old laptop, that will be sufficient to run this software, Start Pro. If you want, I will also share you the link from where you can download this for free of cost, and you just have to follow the instructions given there. And it's a small crack version. You can just install that, and this software will run in your system. Okay, so
Thank you, thank you, sir.
you don't have to go for the licensed version because that is for professionals. And if we are learning, if we are in a learning stage and if we want to understand how to use this thing, we can go with a crack version. Of course, that is not the legal way, the ideal way to go for it, but we don't have any other option. We can either go for student version, but student version is also not really good. It's better we use a crack version. Officially, I cannot tell you, but yeah, I am telling you right now. And for your second question, if you want to practice this as a structural engineer, how you should go ahead with this? First of all, you should have the understanding of how to model these things, how to run these things in your system, in your software, and you should connect with all the architects in your locality, in your area. You should meet with them and you should tell them that, yeah, I am a structural engineer and I have designed, I know how to design and how to analyze these things. And it's better you should collaborate with some of the architects in your area. And when these architects and these contractors get any projects, you can work with them and you can charge the fees accordingly. In generally, in my area or in Pune, it's around 5 rupees per square feet for a residential building or something. And if you have a if you have a MIDC area in your nearby locality, there are many industrial sheds being constructed. You can just visit there and you can meet with the contractors who are doing this. But the problem in India is most of these designs are done directly with some rough estimate by the contractor or the by fabricator on the site. So you can go there, you can meet with the client and you can tell him what are the advantages if he does a proper design. And also the structure will be safe in case of cyclone, in case of wind. If he goes with a normal directly if the contract is constructing on site. That is of course unsafe, and that should not be practiced, but in India it is done. So you can talk with the client, and initially maybe you can have some discussion with the contractors, with the architects, and for them you can provide this design of structures on in the MIDC area near you. This is one of the approach. And other approach is, of course, you can work in some of the structural consultancies which are already established. And once you have sufficient experience and if you have sufficient understanding, side by side, you can slowly start simultaneously working on some projects. And when you have enough work, and then you can full time start your consultancy. So yeah, that could be one of the approach.
Thank you.
But the basic thing which you should have is you should have thorough understanding of the projects. You should have thorough understanding of the software and how you want to run this and how you want to implement these things. If you have a proper understanding of how these things are modeled and how these things are designed, then you will have the confidence to go in the market to meet with the architects, with the clients, and you can tell them, yes, I have designed this and I can design this in a more optimum way and in a more good way, which will help the client and even the architect to deliver a good result to the customer. Okay, so I would also like to share with you what we are offering is, also we are, for a structural engineer, for an engineer who is maybe in his fourth year, or maybe he is in his third year, or maybe he has completed his engineering and right now he's working with some consultant, or right now he's working as a engineer on a construction site and he wants to shift from that to designing area. Then we are offering a 3-month course where we will be presenting you how you can use this tool STAD Pro to completely design any of your steel structure. Okay, though, so this program, in my last 8 years of experience, I have majorly worked on steel structures. I have designed various kind of steel structures. So I am focusing on steel structures using STAD Pro. In my MNCs, I have also used many different softwares, but if I compare the Indian market, in India, most of the professional they go with STAD Pro. So I will be explaining you how you can design any kind of steel structure using STAD Pro. So we will have this first module in which I will be covering the basics of structural analysis of steel structures. Then we will study the intermediate level, which will be designing of these steel structures. The analysis is one part, designing is the other part. So I will be explaining you both these modules in a separate sections like beginners level and the intermediate level. Then in this advanced level, we will have many of the real-time projects where we will see what are the input which we get from the client and how we work on them and what is the output which we give to clients. So we will deal with some of the real-time projects. In this beginner level, again the beginner level is bifurcated in some chapters, and each chapter is again bifurcated in some lectures. We will have the introduction to steel structure, then we will study the structural analysis fundamentals, we will study the modeling of these members in STAT Pro, we will do the static analysis, and we will also study the dynamic analysis. In static analysis, we will have the dead load, live load. In dynamic analysis, we will have the wind load, the earthquake load. That is module 1. In module 2, we have the intermediate level where we will be understanding first the design code and the standard which we have: IS 800, IS 875, part 1, 2, 3. We will be understanding how to design the connection, the fillet weld connection, the bolt connection, the shear connection, the moment connection. We have various kind of connections between two members. So in this part 2 of my intermediate level, we will be understanding all kind of steel connections. Then we will understand how to design a simple beam, how to design a simple steel column. how to design a frame, how to design a truss. So all these four type of component will be covered in chapter 3 and 4. Then we will evaluate the behavior of all these various separate components. That is the evaluation of structural behavior. That will be my part 2 of the intermediate level. Once you are done with these two modules, the most important module is the advanced one, that is the real time project. Here we will be dealing with various projects. First, we will analyze and design a steel warehouse. Right now, what I had shown you is a PEB warehouse. Before directly jumping to PEB warehouse, we will study first how to design, how to analyze a standard warehouse. I will be showing you one practical project. What are the client documents? What are the output which we give to him, and how we. I will show you the workflow, the path in which we design these things. First, we will go with standard steel frame. Then we will go with PEB structure, then we will go with a structure with a roof. So in 3.1 itself, we will be designing 2 to 3 projects of industrial steel warehouse. Then in part 2, we will be studying how to design and analyze a steel building of G plus 5 floors. So there is a project of G plus 5 floors of steel building, and here we will be dealing how we can analyze and design this kind of building. Generally these kind of structures are not in India, because in India we don't have steel buildings much used, but certainly in certain things we use them. And as a structural engineer, you should be aware also in case of steel building how you can apply these loads and how you can apply the result. So we will be dealing with analysis and design of steel building, a practical project. Then of course there are many other steel structures, like we have the billboards, canopy structures. Like you might have seen a toll plaza. If you want to design a toll plaza, what are the conditions which we consider? If you want to design a advertisement hoarding, when you go along your road, you might have seen many of the large steel structures and advertisement hoardings. These all are also structural components, and as a structural engineer you should be aware how to design these things. It's not only about building an industrial warehouse. If you see around your world, as a structural engineer, you can work on many projects. But our mind during our college days and during even our initial professional days, we are only focusing on some of the residential buildings and maybe a few industrial buildings. But if you see outside the world, there are many things which you can design. These are the billboards and canopy structures. Next, you have the infra project. While you might have seen the construction of many uh, infra projects, like you have these roads, you have flyovers, you have this metro being constructed in many cities. While constructing these things, of course, this is a structural member, the RCC structure, like a bridge and all. As an individual structural consultant, in your initial days you cannot be in a condition to design a bridge on your own, because that requires much experience and a wider team to deal with it. But there are many of the small components in design of a bridge which even a small consultant can work with. For example, we have these steel truss and trestle assembly. We have these temporary structures which are used, the scaffolding system, the cuplock system, the formwork system, which are used to support our main bridge. These all are steel structures and they are temporary. They are only up till the point when our main structure is being constructed. So even for this construction, we require structural engineering, and these things also we can do as a small structural consultant. And we can approach the contractors, the subcontractors on the site, and we can tell them, yes, we have this experience and we can help you in planning and erecting your main bridge. Of course, the design of main bridge will be done by maybe some big companies, but the the truss and trestle assembly which we have below it, the erection methodology which you have, that can be provided by a small consultant. Most of the time, the subcontractor tries to do it on his own, but he might not have the time or the expertise to do it. if you have the expertise, or if you have done one or two projects, these kind of projects, you can approach these subcontractors and these contractors on a construction site, and you can be in a position to give them the design of maybe a couple system or a truss system or a supporting system for a bridge, for some working platform area. So we will cover a project recently, not recently, maybe in 2018-19. I was involved in a team where we erected this whole truss and trestle assembly system to construct a large 100-meter span of a railway bridge, which was a bowstring girder bridge. Of course, the bridge was designed by a big company, a big structural consultant, but the truss and trestle assembly below that, that is designed by many of the small consultants. So I was lucky to be involved in such a team, and I will be explaining to you how we approached that project and how we designed it in a structural engineer point of view. So that will be covered in this chapter 3.4, design of truss and trestle assembly. Finally, we will have a course review. We will understand from module 1 up till module 3 what all we have studied. We will try to summarize this thing, and that will be covered in our final chapter. So this is a short course which we are providing, and if I want to summarize to you in one page, this we will have these 15 chapters, 5 chapter in each module, and each chapter is again further divided in 3 lectures. So this is a complete maybe a 3-month course, and every day, from Monday to Friday, every weekday, we will have around 1 to 1.5 hour discussion on these chapters. So this is what we are providing to you, and to get any further detail related to this, you can contact me. uh, I will be sharing with you my details. uh, okay, I will just share my WhatsApp number in the chats. It's 7875605154. Okay, you can contact me if you would like to have any other information related to the course or any other information in general. Okay, let's see some of the questions. Sir, CPE and CPI calculated. One is having maximum and other is having minimum value. So which value you take for design? We have, while calculating the CPE and CPI, of course, there are various values, and we have 8 kind of wind loads. So in general, in college, what we do, we just consider a maximum value and we design our truss for that maximum value. But we cannot say which is the governing force if it comes to a 3D structure. So what we do is we apply all these 8 wind load cases in our structure, and the STAD designs each and everything, and he checks which is the worst condition. Okay, so slightly maybe I've answered your question, Zubair Sheikh. Next is Ranjit Kale, how the tapered section is created. If you go in your properties section of your STAD Pro, you have the option for define. One option you have for standard section database. If you click on section database, you can get all your standard section. And besides section database, you have option for define. If you click on define, there you have another option for tapered eye section. If you click on tapered eye section, you get F1 to F7. Certain values you have to enter. Based on those values, you can create a tapered section. Okay, so maybe those were some of the few questions. And if anyone wants to ask any question, either you can unmute yourself and ask a question, or you can just type in a comment. And if everything is fine, we can conclude this section, and I would like to hand over the section to Mr. Abhishek sir.
So thank you so much, sir.
Welcome. Yeah.
So the session will be next session will be starting soon. So all of you just remain online. The next session will be by Professor Mirza Asif Beg sir, who is acting as the head of the Civil Engineering Department in the TGP CET Nagpur. Coming to this session was very nice, and the actual design is been shown as well as the live project is also shown by the engineer Jisan sir. So he has also shared his contact number if anyone want more information, or if they want to, if anyone want to have some sort of more information, or any, if someone want to learn the structural design through its course, then definitely they can contact Mr. Jishan sir. So thank you, Jishan sir, for your session. And now we'll start the third session just in a few minutes. So good afternoon all. So today we are having the third session of our STTP of the day 4. So this session is going to be delivered by the Professor Mirza Asif Beg sir. He is currently working as a head of the department in TGP CET Nagpur. Sir is just going to complete his PhD from the Nagpur University. He has submitted his thesis in the structural engineering domain. He has completed his master's from the Nagpur University, his bachelor's from the Baba Saheb Naik College of Engineering, Pusat, through the Amravati University. Sir has handled many portfolios in his institution. He has published many research publications in the journals and conferences. He has attended, participated in many conferences, workshops. He has delivered 20 lectures for the AICT sponsored Prerna Screen. Also, he has been resource person for the many of the faculty development programs and short-term training programs. So I welcome Professor Asif sir and I request him to start with his session. Thank you.
Is it visible? Am I audible to all? Am I audible?
Yes, sir.
Okay. Is my screen visible to everyone?
Yes, sir.
Okay.
Yes, sir. Yes, sir.
Very good afternoon, all, and welcome you all in 1 week short-term training program organized by Mauli Group of Institutions. Uh, I really grateful and thankful to the organizing team and convener of this STTP, Professor Abhishek Limbekar, and one of my friend Gajalan Sherke for inviting me in such a wonderful short-term training program. As only not only I am uh, I'm not delivering the expert lecture, but also the participating in all the lectures which has been done in the earlier days and the earlier sessions, and it is really useful to have and to learn the recent trends in the civil engineering, and that's why I have choose to take the topic which is uh, not very much related to the recent trends of civil engineering, but yes, for me, I believe that without consideration of sustainable development goals in any recent trends of any engineering field, it won't help to the society, to the environment, and to the economy. So that's why I come up with the topic, the evolving roles of the engineers towards achieving the sustainable development goals, looking into the built environment as the population of the globe has been increasing drastically, and whatever the resources which we are having with us, looking into that consideration of that things, we have to do the engineerings for the sustainable developments. So these are the content of today's lecture, in which we will be having the introduction on the system of which we have to stick and we have to achieve the sustainable development goals, and what are the engineering roles which we have to redefine, what are the key criteria to be set for having the sustainable development goals, and various educational challenges which we have to face and which we have to overcome from the traditional method to the future education system, and what are the development projects. So this will be the few contents of today's presentation. Now, in the introduction part, the nested system of the sustainable development is shown here, which the environmental system which we can say which is inevitable and provides the context in which everything else is set. So the outer course is the environmental one, where the laws of the nature are non-negotiable and everything must be operate within them, and thus the environmental system supports and makes human activity possible. So whatever we have to do is in looking into the environmental system, which is the outer core of the system, and within that system environment, within that system we have to create society which operates in accordance with the instinctive and the creative which has been invented the economic system to serve its own purpose. And economics cannot function in isolation from our decisions, since without us they would not exist. So this is the three layer nested system which is shown the main elements of the sustainable development. So whatever we have to invent, or whatever we have to provide to the society, we have to look into two major segments, that is the environment and the economy. Now engineer works uh, in three systems, that is the environmental system, social system, and the economic system, which provides the product where the society interacts with the economy, and the infrastructure at the society or the environmental boundaries. So as a result, what we can say, the engineering activities have the major impact on the world. Consequences range from the quantity of non-renewable resources used and the changes made to the of uh, quality of the natural environment. Natural environment is nothing but the environmental system to effect on the pupil through the services to support human gathering, that is nothing but the social system. And engineering also likely to require and we can say the generate large amount of money, that is nothing but the economic system. So these three system, environmental system, social system, and the economic system, these three systems we have to be focused on being engineer. When viewed in this way, the similarities between the engineering activities and the fundamental elements of the sustainable development become apparent, even if this is not always recognized. So, particularly by the engineers themselves. Now, engagement with the sustainable development must include the improvement of the built environment, which serves the most basic human needs in terms of shelter, water supply, sanitations, infrastructures, social organizations providing these essential services, and many other things which provide these essential services necessarily impact on the natural environment. And as the rapidly growing human population is further increasing the demand for societal and physical infrastructure, the need of provide these in a sustainable way is also growing. Engineer provides this infrastructure that underpins society at all levels. Civil engineering provides the basics on which people can build their lives. Consequently, the discipline is both vital to the intimately affected by the principles of sustainable development. So, what things which we have to remember while working on any engineering works, that what things we cost, and how to make a business out of providing the infrastructure or the goods or the services, that comes under the economic system. What impact those things have on the nature and the earth supports, that comes under the environmental system, and how those things serve the needs and the quality of life of people and their communities, that reflects under the social system. So these three systems we have to be remember, we have to consider to for building any engineering works. Now, moving towards the next topic, that is the built environment. The urban population has increased markedly over the last 150 years. In 1850, there were only two cities in the world with over 1 million population. I think London and Paris. And by 1950, only Greater London and New York City had populations over 10 millions. Now, almost half the global population resides in cities, many of which have populations larger than some countries. So, these moves have resulted in a dramatic shift in the way humans fit into the ecosphere. There are currently 26 metropolitan areas with population of over 10 million people, and of those only 7 are not in the developing countries. So there are 61 mega cities in total, and of those less than one third, that is 18, are not in developing countries. The mega cities currently account for around 7% of the global population, and this proportion is likely to increase. In high income countries, there is often a high urban population as a percentage of this total country population, with up to 80% living in cities and the town, and this can have a detrimental effect on the environmental system, with over two-thirds of the world pollution being associated with cities in rich countries. Furthermore, due to the separation between the production and the consumption, the inhabitants or the population of these high income cities may be unaware of the degradation of the resources based on which they depend that result from their consumer lifestyle. The way that cities develop in coming century will be a key factor in achieving a sustainable future or not. Anyone involved in creating the built environment will have a major role to play contributing to sustainable development of the cities. Now, looking into this already built environment, when we talk about the highly growing population, professional engineers have a sound understanding of the scientific principle that underpin both the natural and the technical world, and they already have many of the skills necessary to address sustainable development issues. However, widespread practices still needs to reflect this. It is suggested that achieving human well-being within the sustainable development constraint may be as a pivotal a moment in history as when the agricultural age gave way to the industrial area. So, achieving sustainable development presents different challenges compared with other dimensions of the built environment management problem. This includes issues such as longer time perspective, wider social, political, and economical context, lack of frameworks, absence of feedback mechanism, and weakness of the evaluation tools. And hence, engineer needs to re-evaluate their roles and responsibilities in the development process and readdress what it is we are trying to do to demonstrate that we have an understanding of the broader issues and that we are able to construct appropriate solutions. Now, when we talk about the engineering roles and their roles redefining, engineers needs to embrace, expand their design space, and formulate more holistically conceived solution to any given problem. So, to achieve this, two areas must be addressed. First one is the clear guidelines need to be articulated that helps engineers both develop and assess the sustainable development implications of their work. And secondly is achieving the necessary skill to implement sustainable development requires modification to the way engineers are educated. In particular, there is what we can say the need for the engineers to consider the social system aspects of sustainable development rather than the more conventional consideration of balancing environmental protection with economic growth largely through the cost benefit analysis. Engineers have been part of the problem as well as its potential solution, and that now the engineer's roles may be more about conserving the quality of the resources we have left. So engineers have already contributed very largely to the society, but are misunderstood group as their efforts are often underappreciated. The delivery of the most services essential to modern life, such as electricity, flight, television, medical imaging, sewage network, the telephone, water networks, and railway lines, and etc., are the results of the engineering. Now, moving towards the next, that is the widening horizon, in which the 8 elements are given and which is based on the three major sectors, that is the quality, time, and cost. Much has been already written about the sustainable development, such that it is often hard to make the necessary connectivity with engineering at day-to-day level of the practical implementations. While classical civil engineering activity has aimed at satisfying three overarching requirement, and these three overarching requirements are the quality, cost, and time. A wider framework is need to help guide the engineers towards solutions that are more responsive to real needs, especially important in many development situations. This helps to define new enlarged solution space which accepts but goes beyond consideration of economic probability, profitability, and market condition and competition as the drivers behind the choice of solutions. Such frameworks has been proposed which attain to deliver the sustainable development debates through encouraging engineers to work within the wider system boundaries. So these this is defined through the elements like ethical foundation, future vision, interlinking scales, system context, holistic financial accountability, maintenance of natural capital, efficient health infrastructure, and justice through the participation. So these 8 elements are defining this wider system, this widening horizon, which is based on the quality, cost, and time. This we will see one by one. So first, we will see what is the ethical foundation, which can be provide the intellectual underpinning, the and hence the justification for seeking a specific course of engineering action uh, or any avoidance. It links the project proposal, the policy environment that relates to the project, the people affected by the project, and the professional team involved. And hence, it encourage engineers to explore the justification for a scheme and how it fits with the prevailing policy, end users, and the environment. The second element, that is the justice through the participation, covers the area of social equity, equal rights for the development, democracy, public participation, and empowerment. It also requires engineers to be careful in terms of transparency and justification in decision making. In many projects, we can see there are injustice while taking the decision, the uh, looking into these segments like public participation and the empowerment and the democracy. But these things we have to be very careful, we have to be taken into the consideration while making any kind of the decision. And the social implications of development should be considered at the engineering design stage, taking into the account any cultural, religious, ethnic, or gender issues that might be relevant. The benefit for key recipients must be considered as well as ensuring that the effects are not over damaging for the rest. Genuine concern should be embraced through the willingness to adapt and modify designs and process of managing this agreement accepted by all the parties. So justice through the participation must be there, and yes, it is of course a vital element of this widening horizon. Now, moving toward the third, that is the efficient, healthy infrastructure or the coordinator structure, we can say, in which three segments are important. And in consciously shaping the built environment, the engineer should be striving to create infrastructure that is ecologically acceptable, energy and resource efficient, and contributes to healthy, vibrant, and cohesive living spaces. So these three segments which engineering services such as transport system, water, sanitation, communication, network, flood, defenses, buildings, and other aspects of the urban fabric impact on the lives of all those who live in towns and the cities. Sometimes with sometimes there may be a negative consequences like traffic congestions, pollution, visual impact, noise, and water system failures, etc. But we have to focus on these three things while we have to build the efficient coordinated infrastructure. Areas of good practice therefore include the use of alternative building material, minimizing waste, maximizing energy efficiency, and facilitating recycling and material conservation. So whatever the project we are adopting, being a civil engineer, we have to be focused on the minimizing waste, like whatever the natural resources we are using for the construction or any other civil engineering works or any other engineering works, we have to minimize the natural resources, and we have to recycle the thing, or we have to maximize the energy efficiency work, or whatever the material we need to conserve, that thing we have to be more focused on. Now, moving towards the next, that is the fourth element of the wider system, that is the maintenance of the natural capital, in which already the recent trends have been increasingly tight environmental constraint being imposed on engineering activity. Indeed, the ability to mitigate environmental impact has been seen the minds of the many engineers, and which is evidence that sustainable development is being addressed and achieved, which the need to maintain the ecosystem diversity is very much important there. It is not presented here as the sole or overriding driver, but nevertheless opportunities should be sought throughout the enhancement as well as the mitigations. So whatever the natural capital which we are having, that we have to restore, we have to maintain that ecosystem, and and we have to balance the environmental and the natural resources. Now moving towards the next, that is the system context, in which the issues such as the environmental degradation, poverty, and economic success are fundamentally interlinked and can only be addressed through integrative management. The linear approach to procure, design, build, operate, and decommission can lead to a failure to the recognized and wider context, in which engineering takes place as a part of a series of complex systems with feedback loops involving society and the environment. A system view should help avoid the what we can say the possibility of merely translating a given problem into the more remote states of other responsibility. When we talk about the interlinking scales, sustainable development can be viewed very difficult, very different from the perspective of individual lifestyle and collectively at regional, national, or the global levels. But not only should distant spatial impacts by considered that may seem beyond the perceived remit of the local engineer, but intergenerational interests also need to be addressed and protected. It is, I think, the duty of the engineer to address aspect of the project that affect future generation and seek uh, what we can they seek to develop the design and strategies in anticipation of their needs as well as those of the present. This raises the difficult question of where the boundaries of any engineering project should be set and how far its influence should be considered. Now, one element which I am skipping here, holistic financial accountability, but the very important aspect of this widening horizon is the future vision, and I'm I'm very much confident about my statement that the sustainable world can never be fully realized until it is widely envisioned, while accepting that vision without action is useless and needs to be disciplined uh, without any doubt. Vision is necessary to guide and motivate and leads to a continuous need for reinvention of engineering practices and challenging attitude towards the traditional procedure, which may have been conceived within much narrower frameworks suitable for its time, but no longer capable of meeting modern challenges. These encourage the setting of ambitious goals and target that stimulate creativity and innovation. So these eight keys elements provide the wider boundary for the framework we are seeking, which help contextualize engineering activity against a backdrop of sustainable development. The focus here is on the problem definition, and many of these elements translate most effectively into what we can say the early stage of the project delivery, impacting on the scope and the feasibility stages, as well as on the aspect of implementation through the design, construction, and operational stages. Now, the next content of this sustainable development goals is the key criteria, where the set of key criteria that can be used to guide engineering activity is proposed in this table. Addressing the summary questions can help to structure consideration about the contribution of the project towards sustainable development, including identification of trade-offs made between the key criteria. So, what are these eight criteria, and related to that, what the question we must ask ourselves before going or heading towards any project work that is mentioned here in the table? And consideration of these key criteria can illustrate whether short-term benefits are being made at the expense of long-term requirement, and this may suggest a route to varying the development path to allow for rectification of these as required. The aim is not to use the key criteria to identify a perfect project, but should be such but should be rather to use these lesson learned to allow individual project to contribute to the further development. It is also worth remembering that significant lessons sometimes can be learned from the problem more readily than the successes, and the valuable knowledge gained in this way can contribute to iterative improvement in future project. So, looking into these eight criteria and what questions which we have to ask, that we, that is the more focused one. And the very first criteria is the project is maintainable. So what question which we have to ask is, to what extent can the development be operated, maintained, and renewed without external intervention? For second criteria, whether it meets the need. So what question we have to ask is, how does the development contribute to address a need, and in what ways does the development contribute positive benefits to the recipients and the wider community. So see, there are the few projects which are some positive points, which are having some negative points, but which points we have to carry in a positive way, that we have to focus, and we have to see whether these benefits to the larger community or not. So that we have to see in the criteria. The next criteria is the culturally appropriate. So the question arises, how culturally appropriate is the development, considering who was responsible for its assessment. Next criteria is about the affordable or the economy. Are those responsible for the initiation, operation, and maintenance of the development willing and able to pay the cost required? So the next criteria about the consume resources. So the question may be asked about this key criteria is what level of consumption of renewable and non-renewable resources is caused by the development, and how appropriate is this consumption. So I think by these questions, if some engineers or someone asks that these questions to self one, we can definitely have the contribution in to achieve the sustainable development goals. Now the next criteria which is set is not excessively damaging. So what question we have to ask is the what of effect does the development have on the condition of the global commons and on local resources including human and the social capital. The next, that is, promotes equity. In what ways does the development increase intergenerational equality, addressing issues and gender equality, reduction of poverty, and the improving rights for the children? And the last key criteria for to achieve the sustainable development goals is to allow the future development. Does the development allow for future development possibilities, and in what way are future development constraints are there? So these eight criteria are set looking into the development of the engineering projects in terms of the sustainable development goals. Now, what are the development projects? Applying the principle of sustainable development to practical development engineering requires a wider perspective to be taken by the decision making engineers in terms of the spatial and the temporal impact arising from the action and decision taken. It is, I think, important to consider the wider framework discussed here, in particular when providing basic infrastructure in poor communities. In these cases, often the engineer has a direct contact and engagement with the recipients of the development engineering project, and therefore is likely to experience or observe more directly the benefits gained from the consideration of sustainable development than an engineer who is more remote from the recipients of their decision. By considering the key criteria questions that which we have already seen, it is evident that the number of similarity exists in the way engineers can contribute to sustainable development, no matter the environment in which they operate. However, what is important is that decisions are made in relation to case specific consideration. It has been found from the field research that output, that is the physical infrastructure elements, are often counted as a mean of measuring success rather than assessing the less quantifiable outcome that the project really strove to achieve. So for example, suppose we have installed the wells in a particular area. So so the number of whales, counting of number of whales, rather than monitoring improvement in health, that was the reason for installing the infrastructure, that is important. So the counting of the number of whales which we have installed in particular area, more than what is important is what the benefits we are getting from that whales, whether the whatever which is collected from that whales is healthy or not. So that concern must we have to be considered in our minds while going for any engineering projects. So uh, these are the development projects which we have to remember while going for any future projects. Now, what are the educational challenges which we have to face is, as the engineers of the future will need to consider the consequences of their development, and more importantly of their own action, if they are to contribute to sustainable development, and it is therefore vital that the broader issues of the application of technology are included in their education and training. So to be very effective in addressing the pressing problem facing global society in the 21st century, engineering education needs to evolve and embrace some of the soft skills
Excuse me, sir. The screen is disconnected. I think the shared screen is disconnected.
is it visible now?
Yes, sir.
Okay. Okay, so we were talking about the traditional academic courses which reflects the technical or what we can say the problem solution solver, but it is essential the requirement that the engineers develop a rigorous understanding of the physical and what we can say the mathematical principles through which their designs will function. But engineering design is only a part of a spectrum of skills needed in the delivery of the projects, products, and the services. Engineering is affected by and affects other issues that are not so easily defined. So while engineers are frequently seen as the problem solver, much greater emphasis need to be placed at an earlier stage in process the real needs underlying each issues are accurately met. This requires dealing with the non-technical details and what we can say the future engineer must have an understanding of qualitatives as well as the quantitative aspect of of their practices. So these three things which we have to focus more on while we're talking about the educational challenges to prepare the future engineers, that is the soft skill problem solver, and the engineer must be, have the qualitative and the quantitative aspects. I'm moving towards the concluding remarks of this presentation, as I have many uh, numerous examples over this lecture, but looking into the time constraint which I have been, because I was ready with my presentation at 1:30, and I have arranged my other assignments and scheduled meeting at 3, and looking into that I am just concluding here that engineer begins to embrace the concept of sustainable development in their everyday work. So particularly when providing infrastructure for the built environment that supports an ever increasing urban population, their roles is evolving. However, if engineers are to be able to fully engage with such an expanded realm of decision making, then their education need to equip them with the capacity to understand and embrace skills beyond the traditional engineering science. By addressing the demand of this wider uh, sphere of problem solving, engineers can enhance provisions of infrastructure in the built environment in a more effective way than ever before. So, at this, uh, I will just end my lecture, and the forum is now open for any question answer. If you want to have this presentation, I can share this presentation with the organizer team, and whatever the content deliver here, the basic what we can say, the literature has been taken from where I can share also that to the convener of this short-term training program. So that's it from my side. Abhishek Nimbekar, sir.
Yes, sir. Thank you so much for the wonderful session. The session was regarding the sustainable development and the involvement of civil engineers.
And sorry to interrupt you. I was actually one meeting scheduled at 3 p.m. and I was receiving many calls for that particular meeting. That's why I have just concluded the lecture in 45 minutes only. But I have
Yes, sir.
prepared this lecture for more than 1.5 hours. So that part we can take in another sessions. But sorry for this moment now.
Sir, I think we will schedule one more your half an hour session, maybe tomorrow or day after tomorrow.
Okay, no problem. We will have the discussion on this later. Okay.
Yes, sir. Yes,
Okay.
yes.
Okay. So
So
if
once
any
again,
question, anybody is having any question, you can ask through Abhishek Nimbekar sir. He can float me the questions. I can deliver all the answers of the questions personally to the Abhishek Nimbekar sir. So if there is any question now, you can ask me, or else I can move ahead.
yes, definitely. So I hope that sir will again join us today, tomorrow or day after tomorrow for the remaining session. And once again, I would like to thank him for this session. So actually, sir, one question I would like to ask, and you can answer it briefly.
Please, please, sir.
That yes, sir. In your session, you have mentioned that the civil engineers are the role of civil engineer is very crucial, but it is not recognized on a social level nowadays. So how this can be overcome? Means on a social level, the civil engineers are not that much given so much what we can say social value.
Not only
So
the
how
civil
how
engineers, but
how we
in
can
every.
recognize?
Yeah, yeah, I got your point, sir. But not only the civil engineers, but in all the domains of the engineering, it is what is happening that the engineers are not recognized as much they are working. But for looking into these 17 sustainable development goals, which is offered by the United Nations, if we engineers starts working on these sustainable development goals for the benefiting the society, for having the economical sections, for having what we can say, uh, the third segment in environment. So these things, if we implement the things looking into these sustainable development goals, definitely in future engineering works we will be recognized definitely.
Yes, sir. And nowadays, what happened that it's a psychological thing that people are recognizing the CS and IT engineers more than the civil engineers. So this is the what we can say a social injustice quite a little bit formed. So what you want to say on this, sir?
The engineering, sometimes the core branches are having the scope, sometimes the allied branches are having the scope. This is nothing but a cycle, sir. This is the 5 to 10 year cycle in which sometimes the core branches are highly appreciated, sometimes the allied branches are highly appreciated. But I look all the things in a broader way, that how all the engineering fields look in appreciable way. So that is my vision, to have the appreciation for all the kind of branches or all the kinds of engineering fields which we are having, because see, for any multidisciplinary project, civil engineering, no one is civil engineer without the electrical engineer or without the mechanical engineer. Electrical or AC engineer is no value without the CSE or the IT engineer. So we all are interlinked to each other, and by which interlinks, we have to achieve all these goals which we are having.
Thank you. Thank you
Okay,
so
thank
much,
you.
sir,
Thank you.
for the answer. So I think that sir will again join us in tomorrow or day after tomorrow. So we will have a discussion on it. And now I would like to declare that the session has ended here, and the feedback form for this session will be given shortly. And the links and the details of the tomorrow's session will be also provided on the official STTP WhatsApp group. So thank you all once again.